Mini lesson 1D, probability. Basic probability. The number of specified items out of the whole number of items. The formula is P of A equals A over the total. Joseph owns a small business selling bagels. He knows in the last week 71 customers paid cash, 4 customers used a debit card, and 36 customers used a credit card. Based on these results, express the probability that the next customer will pay cash. First, we want to find how many paid with cash, which was 71. And then we want to find the total. To find the total, just add those numbers together. The probability that the next customer will pay with cash will be 71 over 111, or about 0.64. Spinner outcomes. The table displays the frequency of various colors from the spinner. Let's find the total first. 20. The relative frequencies will be the frequency over the total. We can also convert those to decimals. Our relative frequencies are 5%, 20%, 40%, and 35%. The next kind of probability is a complement. A complement is the probability of something not occurring. The formula is P of AC equals 1 minus P of A. What is the probability of not rolling a 1 on a fair 6-sided die? To roll a 1 is going to be 1 out of the total. The total is 6. There are 6 sides to the die. To get the complement of this, it's going to be 1 minus 1/6. 1 is the same thing as 6 over 6. 6 over 6 minus 1 over 6 equals 5 over 6, which is about 0.83, or 83%. In a bag, there are 3 blue marbles, 2 red marbles, and 5 purple marbles. What is the probability of randomly drawing a marble that is not blue? First, we find the probability of blue. We'll use that by finding the total. The total amount of marbles is 3 plus 2 plus 5. This could be 10. There are 3 blue marbles, so it's 3 out of 10. We're going to have 1 minus 3 out of 10. 1 is the same thing as 10 over 10. 10 over 10 minus 3 over 10 equals 7 out of 10. 0.7, also known as 70%. Let's look at the next page. Probability addition rule, mutually exclusive. The number of 2 or more specified types of items with no shared traits out of the whole number of items. The formula is P of A or B equals P of A plus P of B. What is the probability of rolling an even number less than 6 on a fair 6-sided die? Well, the total is 6. There's 6 possible numbers. And the evens would be, there's 2 and 4. It says less than 6, so we're going to skip 6. So there are 2 even numbers. So then we have 2 out of 6. That reduces to 1/3. What is the probability of rolling a 2 or a 3 on a fair 6-sided die? The probability of rolling a 2 would be 1 out of 6, and the probability of rolling a 3 would also be 1 out of 6. If we add those together, you get 2 out of 6. Those reduce to 1/3, which is about 0.3 repeated, and then we'll say it's about 33.3%. Probability addition rule not mutually exclusive. The number of 2 or more specified types of items with shared traits out of the whole number of items. The formula is P of A union B equals P of A plus P of B minus P of A intersection B. What is the probability of drawing an ace or a red card in a standard 52 card deck? The total is 52 cards. There are 4 aces in a deck. And then for red cards, half of them are red. So it's 26. Now, red aces is half of the aces, 2 of them. To find the probability, we'll add the aces and the reds together and then subtract the red aces. 4 over 52 plus 26 over 52 minus 2 over 52. So that's 30 minus 2 over 52, 28 over 52. These could simplify. 7 over 13, which is approximately 0.54. What is the probability of drawing a king or a club card in a standard 52 card deck? The total cards is 52. There are 4 kings in the deck. Clubs, 1/4 of the cards are clubs, so that's 13. And then king clubs is 1. We'll do 4 out of 52 plus 13 out of 52 minus 1 out of 52. 17 minus 1 over 52 equals 16 out of 52. We can simplify these. 4 out of 13, which is about 0.31. Probability multiplication rule independent. The probability of getting 2 or more specified items in a row. Items are replaced between trials. Formula: P of A and B equals P of A times P of B. What is the probability of rolling an odd number on a fair 6-sided die twice in a row? The odds are 3. There's 3 odd numbers out of the total 6 numbers. 3 out of 6. And it says twice in a row, so we're going to multiply that by 3 out of 6 again. We can simplify these fractions to get 1/2. If you multiply these across, you get 1 out of 4. 25%. What is the probability of rolling a number greater than 1 on a fair 6-sided die twice in a row? Well, there's 5 numbers that are greater than 1, and the total is still 6. It says twice in a row, so we're going to have 5 out of 6 times 5 out of 6. Now, if it said 3 times, you would multiply it by 5 over 6 again. This gives you about 0.694, 69.4%. Probability multiplication rule dependent. The probability of getting 2 or more specified items in a row. Items are not replaced between trials. The formula is P of A intersection B equals P of A times P of B given A. A bag contains 7 red marbles, 6 blue marbles, and 5 green marbles. If 2 marbles are drawn out of the bag, what is the probability that both marbles drawn will be blue? First, we want to find the total. 7 plus 6 plus 5. This would be 18. The probability that the first marble will be blue is 6 out of 18. And the probability that the second marble will be blue, you need to subtract 1 from each of these numbers. So it'll be 5 because there's only 5 blue marbles left in the bag, and 17 marbles because there's only 17 marbles remaining in the bag. We could simplify 6 over 18 to 1 over 3. Multiply straight across, we get 5 out of 51, which is about 0.1. What is the probability of drawing 4 aces in a row in a standard 52-card deck? There are 4 aces in 52 cards. If we drew one, we then have 3 out of 51, and then 2 out of 50, and then 1 out of 49. We can simplify these. And let's rewrite it. 1 out of 13 times 1 out of 17 times 1 out of 25 times 1 out of 49. We have a 1 out of, we'll multiply these 4 numbers together. Let's do 13 times 17 times 25 times 49. 270,725. It would be 1 out of 270,725 chance. Which would be a very tiny number. This e minus 6 means that it's 10 to the negative 6 power. which is about 0.000004. Or you could write it as scientific notation, which is about 3.69 times 10 to the negative 6 power. Binomial distribution. The probability of having R successes out of n trials with the probability of P for each trial. Each trial has replacement. N is the number of trials, R is the number of successes, and P is the probability of success. The formula is n factorial over R factorial times n minus R factorial times P to the R power times 1 minus P to the n minus R power. The hiking club plans to go camping in a state park where the probability of rain on any given day is 83%. What is the probability that it will rain on exactly 0 out of the 5 days they are there? The probability of a success is 83%, so P is equal to 0.83. R is the number of successes. It says exactly 0, so R is just 0. And N is the number of trials. The number of days in this case is 5. We will plug these into the formula. 5 factorial over 0 factorial 5 minus 0 factorial times 0.83 to the 0th power times 1 minus 0.83 to the 5 minus 0 power. Let's go ahead and put this one into the calculator. 5 factorial. For the factorial sign, you just put an exclamation point. For the exponent, you put the caret. And then whenever you have an expression at the top, instead of just a single number, on Desmos, make sure you put parentheses around it so that it actually counts it to be in the exponent itself. We have 0.00014 approximately. If you were to write it as a fraction, we would simplify these. The 5 factorials cancel. This is 1. And then we have 1 minus 0.83 to the 5th power. Which you could also write that out as a fraction. If a fair coin is tossed 4 times, what is the probability of getting at least 2 heads? For fair coins, there's a heads and there's a tails. There's a 50% chance of getting heads, so P would be 0.5. R is the number of successes. It says at least 2 heads, so we could have R as 2, 3, or 4. Also known as not 1 and not 0. What you could do is add up the probabilities of 2, 3, or 4, or have 1 minus the probabilities of not 1 and not 0. The number of trials is 4 times. We'll go ahead and add up the probabilities of 2, 3, or 4. But remember, you could also do it by taking the complement of 1 and 0. Let's plug these into the formula 3 times for 3 different R's. 4 factorial over 2 factorial 4 minus 2 factorial 0.5 to the second power. 1 minus 0.5 is also 0.5 to the 4 minus 2 power. Let's rewrite this. The 2 factorials cancel here. This would give you 4. And so 2 of those 2's down here would cancel. We're left with 3 over 2 times 2 times 2. That's 8. Now we want to do the same thing where r equals 3 and r equals 4. See if you can plug those into the formula. Go ahead, pause the video, and try setting those up. Are these the 2 expressions you set up? From here, let's go ahead and simplify them. Alright, so 4 factorial is 4 times 3 factorial. So we can have those 3 factorials cancel out. 4 minus 3 factorial is 1 factorial, which is just 1. If we add these up together, we have 1/2 to the 4th power. Two of the 2's will cancel, and so you're left with 1 out of 4. And then for this expression, the purple one, 4 factorials cancel. This is 0 factorial, which is just 1. We add these, get 1 over 2 to the 4th power. It's 1 over 16. Combine these together. First, we want to have them have the same denominator. Their least common multiple is 16. To make those all 16, multiply those by 2, the first fractions, second fractions by 4, and then the third fractions by 1. 6 plus 4 plus 1, all over 16. 11 out of 16. So that's going to give you 68.75%. Hypergeometric distribution. The probability of obtaining a specific number r of successes in a sequence of draws without replacement from a population that contains subgroups. Each trial does not have replacement. Capital N is the total population. Lowercase n is how many picked in the population. Capital M is the sample size, and R is the number picked from the sample. The formula is m factorial over r factorial, m minus r factorial, times capital N minus capital M factorial over lowercase n minus r factorial, times capital N minus m minus lowercase n plus r factorial, all over capital N factorial over lowercase n factorial times capital N minus lowercase n factorial. A class has 9 girls and 3 boys. If the teacher randomly picks 4 students, what is the probability that the teacher will pick exactly 2 boys? N, the capital N is the total population. So boys and girls. We have 9 plus 3. So we're going to have 12 for the population. The lowercase n is how many are picked from the population. The teacher picks 4 students, so little n would be 4. M is the sample size. In this case, it's boys, so that's 3. And R is the number of successes, which would be 2. From here, you would plug it into the formula and then put it into the calculator. And then we'll put this into the calculator. We get 12 over 55. Which gives us about 0.22. 22%. A gardener has 12 identical looking tulip bulbs, of which 4 will produce yellow tulips and 8 will become pink. She randomly selects and plants 5 of them and then gives the rest away. When the flowers start to bloom, what is the probability that at least 2 of them are yellow? For this, the total population is all the flowers here. There are 12. For the lowercase n, that is how many there are picked. She randomly picks 5 of them. Capital M is the sample size, which is all the yellow ones. 4. And then she wants at least 2 of them to be yellow. So that could be 2, 3, or 4. We could also do not 0 and not 1. For this one, let's go ahead and find the complements. So we're plugging it in this formula where R is 0 and R is 1, and we're going to have 1 minus that sum. All right, here is the formula plugged in for R is 0. And then you plug in the same thing for the other expression, except for instead of 0 for R, you plug in once. And then from there, you'll put these into the calculator. And if we plug this in, we get 19 out of 33, about 58%.